So this pre-lesson really isn't a pre-lesson because 5-1 day 2 is very similar to 5-1 day 1. So we're just going to start off with a few different looking problems, but the system is the same. So they're bigger, indexes are weird, and you got letters and numbers. That's kind of the difference. So don't panic. Don't look at the tree. No. Don't look at the forest. Look at the tree. We're going to chop one tree down at a time. So we got the fifth root of 32. The first thing you should ask yourself is that a perfect fifth root? 2 times 2 times 2 times 2 times 2. Guess what? It's 32. And the fifth root of 32 is just 2. Now we're going to do that little nifty thing for this one where we go, okay, slide the radican over, put the power in the top, index in the bottom, and reduce. Done. Go to this one, 2 parts. X to the 20 over 4 times y to the 8 over 4. Chop that tree down, chop that tree down. X to the 5th, y squared. Now there will be times where you will see absolute values sometimes in the book around parts of this. If you really want to know what those absolute values are all about, ask me, but I'm not going to cover it. Now this says solve. Well, because I can, I'm going to divide both sides by 2. So I get x to the 5th equals 32. And this is kind of a bada boom, bada bing, do the right thing with a little different flair here. But to get rid of that, I got to take the fifth root. Those two things kind of cancel because remember, I think of it as x to the 5th over 5, which would give me x, and that's what I want. X is. But then I got to take the fifth root of that side, which we know over here is 2. So there's my answer. More coming. This shouldn't take long, this pre-lesson. This problem comes from page 243, example 6. You'll see a picture of kind of a well or one cube pouring water into another cube, and they have the bigger cube pouring water into the smaller cube. Then they give you some information. They say the smaller cube, or I don't know how they word it, but they say there's 2 cubes. One cube has an edge 2 units longer than the other cube. So there's your algebra. This is x plus 2. Then it talks about if this larger cube pours its water into this, and it just keeps pouring, how much water will spill over. So obviously this has a bigger volume than this. So it does tell us that the volume, let me peek here, I forgot. They tell you about this bigger one that the volume is 729. Now, when you talk volume, you talk in terms of cubic units. So it's like, you pick out one of these little cubes up here that's 1 by 1 by 1. There'd be 729 of those packed in here. So I don't know if they are too concerned about units, but they're telling you, okay, the volume of this cube is 729, which means I take this side, it has to be the same as that, it has to be the same as that. Remember, to find the volume, you got to go length times width times height, or length times width times height, maybe that's better. And you multiply them all together, so you get x plus 2 cubed has to equal 729. How are we going to solve that? Take the cubic root of that side. That's the only way we're going to get rid of that, because these two absorb each other. But then I got to do the same thing over on that side. So what happens here? We get x plus 2 equals the cubic root of 729 was actually one of the samples I ironically picked, and it was random, as one of your perfect cubic roots, because 9 times 9 times 9. And you're like, how am I supposed to know that? Well, you might have to climb the ladder. Go 7 times 7 times 7, 8 times 8 times 8, 9 times, and then all of a sudden, boom, got it. So that'd be 9. So x, if I subtract 2 from both sides, has to equal 7. So pause a second. Okay. If I know that x is 7, that means this is 9. We know that. Times 9 times 9. Because 9 times 9 times 9 is 729. But this one would be 2 less, so this would have to be 7. And so we know that this is 7, 7, 7. 7 times 7 times 7 is 343. So if I subtract my big volume, subtracting my smaller volume, 6, 8, 3. So 386 cubic units would just spill over. So that's kind of a fun little math problem.